All right, so we're going to determine the convergence of some series. These are power series. This first one you know is e to the x. So e to the x, that's defined everywhere, right? Like if I plug in x, this series should give me the exponential. So we should expect that our radius of convergence here is infinity. Okay, it should converge on negative infinity to infinity. So let's take and do the ratio test here. Okay, so let's take L equals the limit as n goes to infinity of a sub n over a sub n plus 1. Okay, so we just check that that's the right thing because I sometimes get that messed up. Yep. Okay, so now what's that going to give us? That's going to give us, well, the limit n goes to infinity. A sub n is what? A sub n here is 1 over n factorial. Okay, so we're going to get 1 over n factorial divided by 1 over n plus 1 factorial. So that's actually going to give us the limit as n goes to infinity, n plus 1 factorial over n factorial. But that's just n plus 1 in the numerator, right? And that's infinity. Okay, so the radius of convergence here is from negative infinity to infinity, or that's the interval of convergence, sorry. Okay. And its radius of convergence, let's call it r, equals infinity. Okay. All right, let's take a look at number 2 here. This is number 2 in the section on the book. And we're going to take 3 to the n over n factorial x to the n. So here, our a sub n is 3 to the n over n factorial. We're going to take the limit as n goes to infinity of the absolute value of a sub n over a sub n plus 1. So that's going to be the limit n goes to infinity, 3 to the n over n factorial divided by 3 to the n plus 1 over n plus 1 factorial. Okay, so now when I take the limit of that as n goes to infinity, well, again, I'm going to flip the second end, the denominator, and multiply. Okay, now I'm going to be left with n plus 1 in the numerator and 3 in the denominator. But watch what happens. That's still infinity. So this still converges from negative infinity to infinity. Okay, and the radius of convergence is still infinity. Okay, let's try this next one, number 4. Let me just make sure you guys got a chance to pause it and get it. Okay. All right, number 4. 4 over n squared plus 2n x minus 3 to the n. Okay, well, let's take, and that's going to be, let's take a sub n is 4 over n squared plus 2n. Okay, so we're going to take the limit as n goes to infinity, 4 over n squared plus 2n divided by a sub n plus 1, 4 over n plus 1 squared plus 2n plus 1. Okay, flip the denominator and multiply. The 4's cancel, and I'm going to get n plus 1 squared plus 2n plus 1 divided by n squared plus 2n. Let's play around with that numerator a little bit, although we don't really need to, but it'll be just a little easier to see. So that's going to be n squared plus 4n plus 3. Okay, n squared, and then when I get the FOIL, I'm getting a 2n in there, but I have a 2n here. When I square 1, I have to add to the 2 there. Okay? But what's this limit as n goes to infinity? This limit is just 1. Okay, so this has a radius of convergence. R equals 1, and it converges. So what I like to think about is it converges around 3. It definitely converges at 3, because that's when this is 0, right? And you just get the n equals 1 term. Well, actually in this case, it's from n equals 1 and not 0. But yes, it'll converge at 3, okay? So it converges around 3. So it's going to converge 3 plus 1 to 3 minus 1, or 3 minus 1 to 3 plus 1. Okay, so x is between 2 and 4. Okay, let's move this a little bit over here. Move this down here a little bit, just to give me space to do number 6. Okay, so number 6 is going to be very similar, okay, as to the other ones. Okay, so what's our a sub n here? I'm actually going to simplify it. Our a sub n is n plus 2 factorial over n factorial. But that's going to be n plus 2 times n plus 1. Okay, you can see that, right? N plus 2 factorial is n factorial times n plus 1 times n plus 2. Okay. In fact, never mind. I was going to add a 2, but no, it's not needed. Okay, so now let's take the limit as n goes to infinity a sub n plus 1 over a sub n is equal to limit n goes to infinity. This is going to be in the numerator. N plus 3 times n plus 2 over n plus 2 times n plus 1. And you don't really need too much to see that that's going to be equal to 1 again. Okay? So it has a radius convergence of 1. So it converges around x equals -2. Okay? Remember, it converges around whatever makes this 0. I actually think the typical word they use is about. X equals -2. So that's going to be from what? -3 to -1. Okay? All right, I'll see you all in the next video.